So we're going to talk about some special circumstances with equations. We're used to getting an exact answer, and there's going to be times when we don't. So if you look at these, if you fill in the blank with a number, if you look at letter A, 2 times what equals negative 10? I mean, the only possible answer there is negative 5. And if we skip over to F, 15 plus, the only possible thing that'll work there is 10. So those are equations that we're used to that have one answer. Then there's going to be equations that any number would work. So if we look at B, 5 times what will equal the same as 5 times, and if you have to use that same number, if the blank has to be the same. So, I mean, you can put anything in there. 5 times 3 is the same as 5 times 3. 5 times 6 is the same as 5 times 6. It's always going to be the same. So anything will work. So there's an infinite number of solutions. Same with letter D. 12 plus, I mean, you can put any number in there. 1 is going to be the same as 12 plus 1. Any number you can fill in there. Because if it's the same over here, then it has to be the same over there. So 12 plus 11 is the same as 12 plus 11. So you have the equations that have one answer. You have these type that are going to have any number of answers. And then you have the type with C and E that have nothing that will work. There is no solution. So if we go by the rule of that the parentheses have to be the same on both sides, if we put 3 plus 6 is equal to 5 plus 6, that is not true. So down here, if we do 5 and then put a 5 here, 5 minus 2 equals 5 plus 2, that is not true. So those would be the types of equations that there is no solution. So going down here, the type of equations that have one solution, they only have one number that will work to make the equation true. So if we create an example, it's just your basic equation, like, 3x plus 12 equals 21. Those are the ones we're used to. You minus 12, divide by 3, and whether you get a whole number, a decimal fraction, whatever, it doesn't matter. There's one solution. Okay, the next type of the ones that we talked about, one of them was called no solutions. And sometimes people put the symbol, it's a null set. Ugh. It's like a circle with a line drawn through it. That is not a very good one. It looks like this, null set. Okay, so in this type, there is not any number that will make the equation true. So for example, let's say that we have 5x plus 1 equals 5x plus 3. Your number sense tells you whatever you put in for x on each side, you're going to times it by 5, but then on this side, you're going to add 1, and on this side, you're going to add 3. So is there ever a solution that will work? No, there's not. There's no solution. Okay, then the last one. All real numbers. Remember, that's all irrational and rational numbers would work. Or sometimes they call it infinitely many. Infinite. You're on your own for the spelling. Sometimes people just put a big I. So in this type of equation, any number will work to make it true. So let's say that we have 8x minus 2 equals, and then maybe we'll flip it around and we'll have the negative 2 first plus 8x just to confuse us. But whatever we put in for the x, on this side, we're going to times it by 8 minus 2. Same thing over here. Whatever we put in for x, which is the same over here, we're going to times by 8, and then we're going to minus 2. So it's always going to work, so any number will work on those. So you solve the equations just like normal. And so we're going to do number 1, 3, and 4 together for today. So let's do number 1. So the first thing you look for, remember, is are there any parentheses for distributive property? No, there are not. Are there like terms on each side? No, there are not. So I'm going to add 5x and add 5x here. So we are left with 13 equals, and then negative 5x and 5x cancel. Negative 5x and 5x cancel here, and we have 13 equals 13. Is that a true statement? Yep. So that means every number will work for that solution. It does not matter what we put in for x here and here. It's always going to turn out the same on each side. Let's try number 3. First of all, we're going to distribute. So we got 13 plus 2x minus 12 equals 4x minus 7. Okay, and then we're going to put these like terms together on this side. So over here we have 4x minus 7. And here we have 13 minus 12, which is 1. And so we have 1 plus 2x. And then this is an example of where if we keep with our routine of minusing 4x, that's fine. It just, over here it makes it negative, but that doesn't matter. Or you could minus 2x on each side. But sometimes people get confused when the x ends up over on the right. So I'm going to still go ahead and minus 4x. And for running out of room space, I'm just going to go ahead and write 1 minus 2x. Because if we minus 4x over here, we're left with negative 2x. Equals negative 7. And then we're going to have negative 2x equals, and we're going to minus 1. Because this is a positive 1, so we're minusing it. And then we're going to divide by negative 2 on each side. So we have x equals 4. So this is one of those regular equations where we have one single answer, like we're used to. Okay, and the last one we're going to do today is number 4. We're going to distribute. So 1/4 of 8 is 2x. And then 1/4 of 4 is 1 equals 2x minus 4. And then we're going to minus the 2x on each side. And right away, some of you might notice that those are going to cancel out, and we're left with 1 equals negative 4. So is that a true statement? I would hope you know not. And so there is no solution. So we're going to put that null set, or put no solution. Okay, so I'm not going to ask you to do any of these unless we are in class right now. But if you're watching this at home, you do not have to do these unless you would like, or you can wait until tomorrow in class.